Are you proud of what happened here today?
Absolutely. I think we should have gone on in and yanked our senators out by the hair of the head and drug them out and said, no more.
Hey everybody, welcome to another Hacking Wednesday. My name is Taggart. How are you doing? I'm not doing great, if I'm honest with you. This stream was actually, you know what? It's Thursday. That's how not great I'm doing. It was supposed to be yesterday that we did this stream, but the country is on fire here in the United States, and so I was in no place emotionally to talk about technology. Really not entirely all the way there today, but things have calmed enough that, you know, doing something productive is better than just doom scrolling all night, so thought we'd give this a shot. So what we're doing tonight is we're reverse engineering an Android application, which I've never done before. This is going to be completely new for me. I'm learning alongside you. And, not just any Android application that we're going to do. I thought we'd take a known open asset, which is a COVID notification app that's developed by, in this case, the state of California, along with the University of California, which I guess I should say, full disclosure, is and my employer, but also because it's a state entity, we have the ability to take a look at this stuff. Plus, we're not gonna be hacking on it per se. We're just gonna be reversing it and seeing how it works. So we're not gonna try to like compromise the API or anything like that. Just learning. So let's get started. So the first thing we're going to start with is we're going to kind of use the incredible Maddie Stone's intro to reverse engineering Android apps. And I put the link in the chat if you want to follow along with it. And we're going to use some of the tools. Not going to follow the exercises at the moment that she, I think those are her pronouns, that she has here. But we are going to use some of her awesome introduction to how Android reverse engineering works and kind of what we're looking at when we look at an Android app. Yes, she, her are her pronouns. So I was going to bother me if I didn't confirm that that was true. All right, so let's get started. The other thing that you're going to want if you want to check out this application specifically, I'm taking a look at CA Notify. Okay, so that's the one that we have here in the state of California. And they all kind of will use the same sorts of APIs. I suspect there's Google and Apple independently use the exposure notifications API. They have different implementations of it. So depending on whether you're using an Android app or an iPhone, or an Android phone or an iPhone, you'll be using one of these two APIs, no matter what state's contact tracing app that you're using. But I'm in California, so we're going to check out California's. And to get it, I think there is a way to use the Google Play Store to straight download APKs, but there's also a great site called APK Mirror, which will help us out in this regard. And so I just searched for CA Notify, right? And that gives me lots of ways to get at what we're doing. All right, so with it downloaded, the other stuff that I have downloaded based on Maddie's recommendations here, I have, I don't know how to pronounce this, JADX maybe? JADX, is the Android decompiler. Notice that it's not a disassembler, it's a decompiler, meaning that a disassembler is going to give us assembly, right, or machine instructions, and a decompiler is going to take it all the way from machine instructions to readable, in this case, probably Java, right, pseudo Java, or Kotlin, I guess, but probably Java. And then the other thing we have here is Ghidra, and I have the Ghidra decompiler installed as well. Ghidra is from the NSA, but it got leaked, so they decided to open source it. It's a really great disassembler. I use it for other kinds of reverse engineering all the time, particularly good at looking at Windows applications. I like it a lot, especially if you can't afford the full license for IDA Pro, which I can't. And then here's JADX or JADX. We're going to go with JADX maybe for tonight. And here, again, you just want to download the zip. If you need, these are both Java applications, so if you need a Java runtime environment, JADX is packaged with one, and this is not. If you're on Kali Linux like me, you have the JRE out of the box for sure. They ship that so that you can run all sorts of stuff, including, but not limited to, Burp, which is also a Java application. And Zap too, actually. So with those downloaded, we're ready to move on. Now, Maddie's first recommendation to us here is to build an Android app before we start reversing it, which is good advice. Couple of problems with that for me. One, I want to focus tonight on reverse engineering and not building. I've built Android apps before, haven't enjoyed it, and it's been a while, admittedly. Second problem, I really hate Java, like a lot. So whenever I can avoid it, I will. But there are some important things to know about Android applications. For example, what's going to be inside the APK, right? The application package that we're looking at. So first off, we've got the Android manifest.xml, and then this meta-inf folder in which certificates live. That's interesting to know. Classes.dex, which has byte code for application in the dex file format. This is the code that the application will run by default. Now, byte code needs a little bit of explanation if we're not familiar with that term. Compiled languages like C, C++, Rust, Haskell, any compiled language, right, goes from the language that you write in. It is assembled, or compiled into assembly language, and then from the assembly language it goes into machine code, right, the binary format that the CPU knows how to read. In interpreted languages like Java and actually Python, there is a different process. The thing that Java does that allows it to run in so many places is that it uses something called the JVM, or the Java Virtual Machine, and the Java Runtime Environment, the JRE. These allow kind of pseudo assembly, which is called byte code, because it's bytes of text, but it's machine language, but it's machine language that's interpreted by the Java virtual machine, not directly by your CPU. That's kind of what Java code gets compiled to, and then the JVM handles that final phase of getting that byte code executed by the processor. Which is why that extra step is why there is sometimes Java's fast. It's really good, but there is going to be a performance cost to it. So if you're measuring the performance of a Java application and a C application, for example, that does the same thing, or a Rust application that does the same thing, even money is that the C or the Rust application is going to beat the Java application in terms of performance. All right. Lib is going to be where native libraries for the application by default live here, so anything that the application relies on. And assets, so this might be, this can happen especially when malware authors want to try to hide additional code by not including it in default locations. That's interesting. And then let's see, what are we talking about here? Dalvik and Smalley. So Dalvik or Smalley is essentially, yeah. So Dalvik or DEX, Dalvik executable bytecode format, is what we're talking about, right? That's that bytecode that the JVM is going to execute. To read it, JADX is going to turn that into first Smalley, which is a readable version of those instructions. But that's not the same as the decompiled Java or Kotlin, which eventually would be the easiest for us to read. So there is kind of this is the reversing process, right? We start from the bytecode, we bring it back into the pseudo assembly here, right? The assembly instructions for the JVM that looks like this. You can kind of see both how it looks like Java or looks like assembly. If you're used to looking at assembly, we're talking about registers, we're talking about, there's a ret here. You can kind of see how they work together. And there is a link here to the entire Smalley instruction set. That's cool. But luckily, when we're doing reverse engineering for Android, it turns out we won't have to work in Smalley that much. So it can be lifted up to Java. That's huge. And, I will say that decompiling fully compiled applications is a little bit tricky. Unless it's something very specific. If you have a .NET application, right, you can use something like .peak, or I'm forgetting what the open source one is. But you can get those down to C# pretty easily. But other times it doesn't look as good. All right. Launcher activity. Launcher activity is what most people think of as the entry point to an Android application. The launcher activity is the activity that is started when a user clicks on the icon for an application. You can determine the launcher activity by looking at the application's manifest. The launcher activity will have the following main and launcher intents. Intents is an Android programming concept. I'm not super clear on it. If we need to go into it deeper, we can. Keep in mind that not every application will have a launcher activity, especially apps without a UI. So background services might not, but we should. So we're looking for launcher activity, and we're looking for in the stuff inside of intent filter. And we're looking for this in classes.dex, I guess. And what are the what do they look like? So android.intent.category.launcher and .main. Okay. Services. We would expect that in the California Notify application that there would be a service of one type or another, just because of what we know about how the application works. So the basic idea with these contact tracer apps is that they beacon using Bluetooth, right? And so you have this on your phone and it's beaconing to other devices that theoretically are also sending beacons. Now, and they keep a track of how many of these beacons they've received within 14 days. Okay? So like you keep a record of all these beacon IDs that you've had within 14 days, and then if any of the phones that generated that beacon report a positive COVID test, the database looks at who else was in proximity of that beacon and then sends you notifications saying like, hey, you got exposed, right? That's the idea. So in order for that to work, there has to be a service, I think, where the Bluetooth functionality of the phone is being accessed in the background. It can't just be when the app is running in the foreground, right? So there should be a service. Broadcast receivers. Broadcasts can be thought of as a messaging system, and broadcast receivers are the listeners. If an application has registered a receiver for a specific broadcast, the code in that receiver is executed when the system sends the broadcast. This is message-based programming, right? So it's very Smalltalk-esque. There are two ways an app can register a receiver: in the app's manifest or dynamically registered in the app's code using registered receiver. So that's something to look for. And then there should be an on-receive handler. Services and activities can also be exported, which allows other processes on the device to start the service or launch the activity. Android application subclass. Android applications can define a subclass of application. They can, but do not have to. All right. Cool. All right, so one of the things that Maddie says here that we should do before we start our reversing in earnest is understand what our goal is. Well, our goal is to understand the application, but also to find out how is it communicating home. That's really what I'm interested in. I want to know how it phones home. If it's secure, that would be something I'm very concerned about. And yeah, just essentially how this thing does what it does. So I do want to look for API calls. I do want to look for entry points, and that's kind of where we're going to start, is just kind of learning how to do this. So let's get JADX going. If you're following along, I have downloaded JADX, and I have it in my scripts folder. There it is. So I'm going to just go to JADX bin, and then it's executable by itself. So I'm just going to run JADX GUI, and that should fire it right up for us. All right, and then I've downloaded the CA Notify APK, and you can see that APK is one of the supported files. So let's go get it. All right. Well, here we are. What do we have? So this is in resources, right? And this is kind of the breakdown that we just expected to see based on Maddie's breakdown, right? Where we would have right here, right? We would expect to see Android manifest. We would expect to see meta-inf, classes.dex, lib, and assets. And sure enough, assets, meta-inf, Android manifest, classes.dex. Other stuff too, but that's a good place to start. So let's check out Android manifest. And sure enough, here is the activity of exposure notification activity, and it has intents of main and launcher. So this is the thing that is really our application entry point. So right off the bat, we kind of know what that is. And you know what? Even though I'm doing this for fun, I should follow best practices and take some notes. Okay, and let me get... There we go. Now it's on the left-hand side, so my head won't block whatever we write down. And vim notes.md. Do I want a better color scheme? I think I do. Yeah, okay. Okay, so CA notify, entry point. Well, let's do just like initial discovery. I have no idea how I want to organize these notes. So we'll say, yeah, in the Android manifest. What's up? So, how you doing? All right. So we found the entry point. It was that. I don't know if I'm liking this color scheme. Yeah, it's better. You know, I'm not gonna lie. So I've had better days. So has my country. I liked it better without coup. All right. So that's our entry point. What else do we have? Oh, cool. I'm so glad you like the bandit challenges. Yeah, I'm excited to go through the rest of them on Saturday. Okay, it looks like we've got share diagnosis activity. That's another one to maybe check out. Yeah, we got to survive the transfer of power and also, you know, ongoing pandemic. And hey, Los Angeles, we're #1. Very proud. Okay, this is interesting right here. So this is a provider. It's not an activity, but so Firebase is important to know. Firebase is... I saw that. Yeah, full lockdown in Scotland. Real. I had such high hopes that y'all knew how to fix this. So Firebase, if you're not familiar, is a cloud storage / application hosting solution from Google. It originally was independent, and then Google bought them because they were great, and it is great. I've used Firebase for a number of applications. Actually, I taught a course on Firebase that I think is available somewhere on the internet at some point. And they offer a bunch of different services, if we look at products. But I think the important one that we want to look at here, if we look in JADX, is there's Firebase, there's Firestore, Cloud Firestore. So Firestore is their kind of Mongo-esque key value pair database. So, and the other thing about Firebase that is really cool is that it's real time. And that's why I've used it. So to avoid the problems of like WebSockets, Firebase is a cool wrapper for that, where if I write a Firebase app, right, and I'm sending data off to the Firebase, my Firestore, all of the connected clients to the Firebase database know immediately the data has changed, and it has kind of built-in handlers to refresh your view based on the new data. So it makes real-time applications really, really easy, which makes a lot of sense for this, right? If you hit like I've been exposed or I got a positive COVID test, you want that notification to go out to everybody who is in your beacon list in real time. So that makes sense. Now, the thing that also is kind of interesting here is, in addition to obviously there being a Firebase provider, there has to be some sort of authentication. So with Firebase, generally speaking, you know, there are accounts that have full access. And then if you're using the API, there's an API key. And so we haven't gotten there yet, but my suspicion would be that there's an API key in here that we can see, which is like, it's not great, but it's also to a degree unavoidable. And what you want to do is just make sure that the API key has the right permissions locked down, right? I should not, with this API key, be able to, for example, read all of the beacons out of the database. All right, a few other things. You know what I haven't seen yet is Bluetooth. Just in this Android manifest. It may be wrapped in something else, right? But I would expect something like, maybe this is broadcast receiver. Yeah, that might be it. Okay. All right, so some interesting stuff in here. Let's actually, can we look for broadcast in here? Okay. So there's a receiver. Interesting. Anything like Bluetooth? Oh, yeah. So it's in there. It uses the feature. All right, so presumably, maybe the broadcast receiver is what's handling the Bluetooth connection, but we don't know yet. All right. What else are we supposed to be looking at here? Native libraries and assets. All right. Well, let's look in assets to see if there's anything fun in here. Assets, org, 310. Presumably the development shop. Let's do just a little OSINT on that. Hey, guys. Oh. Oh, they're responsible for the Java stuff. Okay. It's not a software development shop. It is date time classes in Java. Interesting. Makes sense. Dates in programming suck. Oh, and so this is a database of time zones, which again makes sense. This is going to be mostly unreadable. But you can kind of see what's going on here, right? Let's see if I'll say, yeah, there we go. Okay, so that's everything that's in assets. That could have been more interesting. We have all this Firebase stuff. Have a good night, Lisso. Thanks for stopping in. Okay, so we've got a lot of Firebase stuff. These are just properties, though. It's going to be all metadata. It's not going to actually have, you know, secrets in it. Let's look at meta-inf just to see if there's anything fun in here. Whoa. And what is meta-inf exactly? Certificates. Okay, so, I mean, yeah, it's going to be a lot of stuff in here. Org 310. Again, more date stuff, probably. Yeah. Date formatting. I think we're ready to take a look at classes.dex to see what's going on there. Now, the trick is that with classes.dex, we kind of already are looking at it because classes.dex became the source code up here, right? So it's not like we can look at this file and see it here. We're going to have to parse through all this stuff. But we now know, because we took notes, the cool stuff that we want to check out, right? So let's start from the entry point, right? Which is com.google.android.apps.exposure.notification.home.exposure.notification.activity. Am I reading this correctly? Do we want to go into com? Like pens. What are you? Okay. Interesting. Com.google, Android. There it is. Apps.exposure notification. Common. Exposure notification. Oh, nope. Not right. Exposure notification dot home, not common. Home. And actually, so we just look at this file, right? And exposure notification activity. Some of this stuff has been minified, but still pretty readable. We also actually, I learned here there's a deobfuscation tool. I don't think it works super well, but it, you know, makes some of this a little bit more readable. They're not single letters. All right, so we have exposure notification activity. Exposure view model. So here we're just, if you're not familiar with reading Java, we're declaring variables here. So declare scope, type, variable name, and then we do or do not initialize it with a value. So public, meaning that it can be accessed outside the class. Type exposure notification view model, which is described, you know, somewhere. Broadcast receiver is new, and then there's a function that theoretically constructs the broadcast receiver. And then we're going to create a class that extends. Oh, there you go. So we construct that C017A, then we create an onReceive, and then on receive, we get a context and an intent, and then we do exposure notification this dot whatever these functions are. All right, so we're starting to get this clear on activity result. On create, okay, this is a lot of setting up the view. Okay. Launch from exposure notification, right? So if you get an exposure notification, this is kind of, when you press on it, this is what you'll follow. Okay, starting to understand how the app works here. Now, if you wanted to test Android applications and you didn't have an Android device, you can get Android images from Android x86, I think. Yeah, so you can download Android x86 from either FOSSHub or the OSDN network, and you can run it on VirtualBox if you want. I was playing with that yesterday. It takes a little bit of finagling, but it works out. Okay, so now we know how the app kind of starts up, but I want to know more about what happens. Yeah, here's my exposure notification application. I want to know more about how like Firebase works, right? Now, if I were debugging, or if I were reversing anything else, I'd be looking for strings, right? So that's something I haven't done yet. And I would like to. So where are my strings? So is there anything else in the manifest? Not really. But if I look in resources, is there anything? Yeah. I don't entirely understand how these are organized, but plainly, if I just go look at values and go to like strings, there's a bunch of stuff in here that might be useful for me to know. So these are strings that are used in the application. And this, I mean, some of this obviously is localization, right? There's English, there's Espanol. I don't know what Phi is. Finnish, maybe? FIL, yeah, because FIL is Filipino. Let's look at the Finnish strings to see if that... Yeah. That's not English. Okay, so we'll just stick with values and strings to see what we have here. A lot of error messages, right? Oh, here we go. I'm getting some URLs. Let's go visit this URL. Okay, so that's just the home page. You have been near someone recently who tested positive for COVID-19. This is deeply upsetting. Okay, here we go. encdn.prod.exposure notification.health. So that's a URL that we haven't seen before. Let's see what happens if we visit that. This is an API endpoint. In fact, if I search for exposure notification.health, I will learn some stuff. Okay. Let's keep going. Test verification API key. All right, we found an API key. And then there's, again, prod.exposure.notification.health/v1/publish. That's an upload URL, which is interesting, right? Let's try to visit that just to see what happens. Okay, we found ourselves an API. Content type is not application.json, which we kind of knew. All right, but we're finding interesting stuff, right? And that's kind of what we wanted to do. Save that API key as well. Oh, you're so long. Oh, Markdown's going to interpret those underscores. Well, that's fine. Ooh, certificate URL, API server.insive.org/certificate. Anything else in here? Something. Oh, we got more API keys. Google API key. Interesting. I do love their underscores and their API keys. Crash reporting API key. That's the same API. That's the same thing. Ooh, snap. Google Storage Bucket, EMPA, ingestion, US appspot.com. That's Firebase. That's a Firebase endpoint. Oh, there's Mike Pence. Let's see who he's... Who are you, Mike? That's not going to work. Hi. Well, Mike, thank you so much for your hard work on our contact tracing application here in California. You're in Austria. Danke schön. Okay. I think we're exiting the useful space here. I'm just going to search for Firebase. Okay. Yeah, so these are all the versions of it. Okay. Yeah, not super interesting down here. This is all about a lot of open source licensing information. Some filled out form filling information like, have you traveled in the last 14 days? Kinds of questions you'd need to answer, right, if you had been exposed. Okay. Well, we have some interesting stuff to play with, definitely. I don't know how this thing takes advantage of Bluetooth. We know that we have it, but we haven't seen it anywhere yet. Look at so this is kind of this is the home, the entry point for the application, right? So this is the broadcast receiver. And there's the exposure notifications.r, whatever that is. And then there's the broadcast receiver. We knew that was interesting, so let's take a look at the broadcast receiver. Now, if I highlight this, I should be... No, apparently not. Let's go to... What is it? com.android. Contact broadcast receiver. I guess that's just part of... What is that? Just part of Android? Let's search for broadcast receiver. Reviver. Okay, there it is. Work.impl.utils.force stop runnable broadcast receiver. There it is. Force stop runnable. Okay, so it's not immediately clear to me that this is actually related to Bluetooth. Maybe beacon? Nothing. Wow. Let's go back to our entry point here. Android util.log. Let's go back to the manifest. Were there any services? Yes, there is. There is a service here called nearby. Oh, that makes sense. We should be looking at nearby. Okay, exposure notification, broadcast receiver. And state updated worker. Oh wait, but this is in exposure.notification. The common. No, so it's, I don't want to be in common, right? I want to be in, there should be something called wake up service. But there isn't. Oh no, okay, let's see. So that's the service name. So we were in kind of the right place. So it's actually common to Google, Android, GMS. Here we go. Nearby.exe. Hey, I think we're on the right track. There, okay, there's wake up service. Okay. Well, this is where the temporary exposure key is generated. Interesting. This is interesting. I mean, I'm not very good at crypto, but this is the code that generates the temporary key for tracking your exposure, right? And it looks like there's some interesting bit shifting going on here. Looks like there's some other bitwise operations, right? There's a bitwise and there's a right shift. So I wonder if I'm not seeing anything that immediately calls out as random, other than maybe the time. So one wonders if there's a way to decrypt the key, or determine some sort of pattern in the keys. But I'm just spitballing. Incorrect value of infectiousness. This is Google sign in. Public iBinder on bind intent and get binder. Okay, let's go. Can we not go to android.os.iBinder? No. Hmm. All right. Well, I know that there's more to hunt for in here, but just to get us started, we know that we have some API keys, right? We know that we have this API, and we have this storage bucket, which is concerning to me in the extreme. Let's quickly check out yeah. So Google actually publishes their Google and Apple both publish the information about the exposure notifications. Sample Public Health Authority app code. Interesting. That's what I wanted. I wanted the API documentation. So this kind of talks about how this works. And broadcast receivers. So this actually might explain how the Bluetooth stuff is working. And this is the kind of open source reference design. Source code, which I wonder how close to it actually is. I mean, this is pretty boilerplate. Let's see if we can get the upload information. So let's, yeah, here's key upload. Okay, so I mean, this looks a little bit more complex, but if we did need to help ourselves understand what something in the code is doing, we could use this reference. To kind of understand what's going on. Okay. So let's talk about broadcast receivers here. Actually, let's learn about everything the API can do, right? Let's not narrow our lens too quickly. This is one page architecture. Okay, generates daily random temporary exposure keys and rotating RPIs. So RPIs are the rotating proximity identifiers for the application. A random ID derived from the device's temporary exposure key. The RPI is generated on the device, and a new RPI is generated every 10 to 20 minutes. Okay, but it's derived from the temporary exposure key. Well, what is the temporary exposure key? A key that's generated... Oh, Charlie, you were here the whole time? My pleasure, man. Thanks for hanging out. Thank you, sir. Well, thank you for being the hero that you are. If anyone doesn't know Charlie Reisinger, go look him up. He's my hero. See you later, man. Thanks a lot. It remains on the device for up to 14 days. In the event that there's a positive diagnosis of COVID-19, and upon permission granted for the use of these keys are provided to the app. Okay, so this is it's randomly generated once every 24 hours. And it remains on the device for up to 14 days. And I think we saw that code. But we can confirm it, right? If we go back to kind of our entry point here. No. Kind of close out everything. There's the temporary exposure key. Yep, we did find it. So this is how the key is generated. And I think we also saw somewhere, I could just be making this up, but I really thought that we also saw somewhere in conduct usual exposure notification, home, Exposure notification activity. Maybe it was in here. That there was code about like measuring something less than 14. Could be wrong, but I really did think so. Okay. But at any rate, it stays on the device for up to 14 days, and in the event that there's a positive diagnosis of COVID-19 and upon permission granted from the user, these keys are provided to the app. Now, that's the part that's different, right? So generally speaking, all this data is like living on the phone, right? It's not doing anything. But if there's an exposure that's notified, which has to start somewhere, right? So like, let's say, hopefully not, but let's say I get exposed, right? Now my phone has beacons to somebody else who's using the application. They get a positive COVID test. They notify through the app that that has occurred. Which actually, oh, did I didn't uninstall it, did I? Can't find it in my apps. Anyway, if I did notify somebody, now my temporary key goes up into what? And that what, I think in this case, is the Firebase, the Firestore. And that is where their backend server logic is saying, hey, well, now that's the question, because the way that Firestore works is that everybody who's connected to the application should be aware of new data, right? So if it's the case that everyone just kind of knows all the keys, like if all the applications actually have the keys, right? Or there's like an how does that work? Maybe there's just like a notification that goes out to everybody that a new temporary exposure key has been uploaded, and then it checks to see if it has yours, or if it matches the ones that you have stored. Now then you're hosed. And the question is, are the keys stored locally, or are they stored in kind of like your own account's Firestore? Which is possible, right? So no local storage whatsoever, which would be weird because they're already going to the trouble of storing it, storing the temporary exposure key locally and whatever that other key was called. The rotating proximity identifier. So this is handled right. Stores keys in an on-device data store. So it is stored on-device. Management of Bluetooth broadcast enables broadcast beacons, scans for other beacons, stores observed RPIs. So it's the RPIs that are getting identified. And remember, the RPIs are refreshed every 10 to 20 minutes, right? So pretty tough. I'm not concerned really with like PHI, or personal identifying information, PII, disclosure here. I'm just really curious how this works. Identifies whether the user was in close contact with a confirmed case. Now, this is like some of the magic that's going on here, right? And a lot of that is about, I presume we'll find it in the code, I hope. But that's really about like, how strong was the beacon signal? Because one of the things I was always curious about with these is like, if my phone beacons to another phone like through a wall in my apartment, am I exposed? Is my phone gonna think I'm exposed? If it's just BLE, then yeah, it will. But there may be some magic math going on to, kind of compensate for that by saying, okay, well, yeah, it beaconed, but this is how strong the signal to noise ratio actually was, or something like that. Provide the files with diagnosis keys and associated metadata. So what's the file format for what gets uploaded? So here's what a temporary exposure key looks like. Start time, end time, region. Repeated keys. And then interesting. So a given temporary exposure key has key data, transmission risk level, which is no longer used apparently, right? And then the report type, unknown, confirmed, test. This is in enum, I guess. Self-report, recursive, reserved for future use, and revoked. This revoke key never returned by client API. Interesting. And days since onset of symptoms. Interesting. So that's what's going up. The problem is that I don't want to, like, I had played with the idea of proxying my phone and testing this. Actually, I did proxy my phone just to see it. I didn't see a whole lot of data going out, which I shouldn't if I'm not reporting a test. But I don't want to report anything because that's a lie. And also I don't want to, I don't want to put bad data into such a critical system. So I don't want to test it that way. So I think for now we're going to stick with just kind of reversing it like this. Okay. If any of you have questions that you want to answer by looking at the code, please ask them. Here's where we initialize the Firebase stuff. And there's attach info, which we can find the usage of, which we did. Okay. Let's see what else we need to learn here. Your app must provide functionality that confirms the user has been positively diagnosed with COVID-19. The functionality controls the release. Oh, thanks so much for the follow. Chaos Ninja. stored on a device whose user is possibly diagnosed. The release keys are sent to your app, which then uploads them. Yeah, okay. So we might want to look at the exposure notifications verification server. Okay. Exposure notification API modes. Now, this was interesting to me when I was poking around at this, just because it talks about version 1.5, and then there's a V1. And if you remember, we found in our notes that we're on V1. So there may be, for whatever reason in this app, there may be some older, maybe deprecated stuff that's going on. I don't know that. I'm just saying there's a V1 here. So, and this is kind of explains sort of some of the difference here. Get daily summaries, get exposure summary. But we saw daily summaries as a function, sort of. Provide diagnosis keys quota 6 per day. Now, again, this is interesting because we did see the number 6. Let me get out of all this Firebase stuff. Get back to the summaries. Yeah. So here's our daily summaries config, and I swear we saw... Yup. So we don't know what this is, right? But we do see a 6. And let's kind of find the usages. Okay, so there's that. There's nothing immediately that jumps out at me that says, oh, that's like the limit of how many diagnosis keys we have. But we can also do stuff, now that we have some language here, we can do some stuff like search for diagnosis. That's diagnostics, that's not the same thing. There we go. There we go. So we're finding diagnosis information. Diagnosis keys data mapping. Okay. And here are our data structures. Transmission risk level. And this is in legacy, this is in V1 only. So if we wanted to know for sure what version of the API we're using, we might want to try searching for this to see if it comes up. Okay, it does. Interesting. There's a lot I can't really get at here, but you see how that we're connecting our documentation to what we're finding in the decompiled source. Okay, so the transmission risk level is set to whatever it is. Let's find the usages here. Stop at field. What is that? It's a bitwise OR. Let's see this transmission is I, whatever it is. Interesting. let's look for the usage of set transmission risk level. All right. Here's our exposure window. All right.